Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. I hope all of you are feeling good. Can you hear me, all of you? Hmm. All right, good. Uh, Guys, just before we start, uh, I want to ask you one thing. That what do you think if we is this time good for all of you? Early morning. What do you think if we can shift this time in the afternoon? Do you guys have any uh, slots available in the afternoon? Hmm. But so you think that in the afternoon it will be better, huh? Yes, I think hmm yes, okay, yes, some students may have some conflict. Normally in the afternoon, what we can have is uh, maybe from 1 to 2. Hmm. How about from 2 to 3? Yes, that's why. Yeah, it will be, I think, difficult for all of you to be available at some other time. Yes. So I think okay, just leave it. This is good. It's okay as we will continue with this morning time. Huh? Yes. How about when the curfew time starts? From 7 to 8. Okay, just leave it. Uh, if you will, if you guys think that there will be any possibility, maybe you can discuss together with with all the members. If you guys have any uh, other group, otherwise no problem, just leave it as it is. So let's go to our work here. uh, we had shared something. Can you see the slides? No. Okay, so do you remember that what was the last yes, I can give you. Just let me know after the lecture. I will show you something. Hmm, yeah. We had finished the last lecture. I think did we finish this method? Create sine wave signal, or this one, where I said that you have to play with the method by controlling these values. You can see here. Yes, first fix the frequency and then keep on changing different and I think and then we said that you can fix this amplitude, which is the volume here, then fix this one and keep on changing this one. So this will be a single frequency, only one beep. You will hear some beep, that's it, a beep of different frequency. And then we said that uh, we have a sound object, and using get samples will return all the sound samples that we will arrange in sample array, that is of type sound sample. So this is the sound sample, and right inside there will be some integer. So we will need this integer using get value. And then after that we also discussed this method, where we said that this is the method that is actually increase volume or to change volume. So we can in general say that you will use this method to change the volume of the sound. Uh, and this is the parameter that we will need to keep it as a variable, and this will be controlled by the user. Now you have to give to the user on the main interface of your project some sort of slider that will vary from 0 to 100, and on the back end, if you move the volume 1 point to other point on a scale from 0 to 100, so a change of 1 unit will bring a uh, change of, on a scale from 0 to 255, that would be like you're going to distribute 256 values over. So approximately actually 2.56 means approximately 3. So 3 units will be changed. So that's what you are going to do with this method here, that give the user the control. And if this value is going to be less than 1, then it will be decreased, and if it is greater than 1, it will be increased. So there is no need to write down two different methods, one for increase volume and the other for decrease volume. So there is also method in your sound class, decrease volume, but you will be writing only one method. All right, now I think after that we also discussed here clip method, which normally takes only two values, the starting and ending point, and using these 2 points we can define the number of samples here, and according to that number of samples we can create a new sound object which we call target, in which we are going to write. So this is your original sound, so a part of it is taken out of this sound, so you perform get sample value at and set sample value at, then get sample value at and set sample value at. So this is your target and this is your source. So what you have to provide is that's it. This indices, starting index, this is 0, 1, 2, maybe this is 4, 3, 4 and 5, then 6, 7, 8 and so on. But this one will be then 0, 1 and 2. It should be 3 samples long. So 3 samples long means, according to this formula, this is going to be here 5 minus 3 is 2 plus 1 is equal to 3. So your target will be of size 3. And after that we are here where we want to do some splicing. Splicing sounds mean together that we have two different sounds, S1 and S2, suppose, and what we want to do is to, this is your one sound and that's another sound, and this is the target sound. So in splicing, what do we do? That we have three parts in the target. That means we are just reading from source 1 and write into the target. So the whole sound is written into the target. So starting from 0 until this index, we will write, we will read from S1 and write into the target, and from S2 we will read from index 0 and write up to the last index, read from up to the last index. So read from S2 and write into the So you will see that S2 starts at this index and it continues up until the last index of the target. So this is the portion, the first half, the first part of the target contains S1, last part of the target contains S2, but in between these two we have to keep some sort of interval where each value in this target sound, each sound sample will be 0. We just want to create here for some instant of time some silence. It's like for example, even if you speak up during our speech, there is always a very uh, small pause, very short pause between the two words that we deliver. That is why we can differentiate between the two words. So that pause is normally even I believe less than 1 second. So for that amount of time, maybe even 1 second or less than 1 second, whatever is the time, we can decide how long that pause could be. So we can connect two sounds together so that they appear that this is only one sound. So how we are going to do this? First, look at the method that is available. Here we will need 3 loops. One loop, we will start from index 0 of source 1 and continue until its get length, the last index of S1, and keep calling get sample value at and then pass index here. This index will be the starting index of S1. So you can say that this is the index here. So once you read this value at index I from S1, you can go to the target and write down this value into the target. So this value is written using set sample value at the target index, that is say t comma the value v, but there has to be into the target object. So we say t dot set sample value at. It's a simple reading from S1, writing into the S2. You enclose this part into one loop, hmm, starting from 0 and until the last index. Then after that, for S2, it will also be the same. But in between, we have here, so you can expect here 2 loops, one for S1 that would contain these two statements, and then another loop that will also contain the same two statements, get sample value at and set sample value at. So you have here get sample value and set sample value. But we said that in between these two loops or these two loops, so one loop is required for this part of the target and the other loop, second loop, is required for this part of the target. So you see this is for loop here and one for loop is here, but there is another loop that we need to write zeros into the middle part, into the silence. That means we will write down here before the second, this loop, the last part loop, we need another loop here that we will execute from the index here where the target index was stopped while writing from S1 into the target. Okay, so this will be your next index in this loop. So here target index will start from that point. We will actually, target index was also started from 0. We continued, incremented it while writing from S1 to the target. So we will not change this target index. We will continue. So when this loop will start, will stop here writing, the target index will remain as it is and it will start from the same point. So you don't need to specify any initial condition for the target index. But in between, we will call here only one statement, not two. We say set sample value at and pass the value with the target index comma 0, because we want all samples to be 0 in between this loop. So there is no time or no requirement for reading any sample, or it will only be used for writing. So I hope that this method becomes simpler. It's so easy that you have two sounds and you just have to perform uh, set sample, get sample and set sample. Now the question here is the problem that how long the silent zone we should have. The length of the silence zone, this one, that how many zeros we are going to write. We know that the silent zone index will start at this point here and will terminate at this point, the last sample of the silent zone. But how we determine that how many times this target index will be incremented? One way is very simple. We can say that okay, you can have, suppose here in this interval 50 sound samples. So 50 sound sample means it's a straightforward way of writing 50 zeros and incrementing this target index 50 times. That's it. So number of zeros can be specified for the length of the silent zone. You can specify the number of zeros, but actually it would not work like this. Second way is that we can have the some formula. Formula will determine that how long duration can be made as silent zone. That means long duration means you can say for 1 second, suppose, or maybe for half second, maybe for 500 millisecond or 700 millisecond, 400 millisecond. It depends on the formula how long the duration will be determined. So that's another. If you use a formula, you have to determine the duration. So in that case, duration will be important for us, and duration will require us for how long uh, duration will require from us that for how long we can uh, have it, say 500 millisecond, maybe 400 millisecond, etc. So let's look at the code first, and there you will see that you have 3 loops, then one for silent zone, and one second loop, and the third loop for the third part. So you can say here you have first part, this is your second part, and this is your third part. So until here, if you guys have any questions for splicing of sounds. Okay. So let's continue. You can see here you have now two different sound objects, sound 1 and sound 2. And what you have to use here .wave sound file. Please ensure that, especially in your project, you will be using only not very long audible files. The maximum length for the sound, that should be only uh, maybe uh, 3 to 4 seconds. 4 seconds, that's it. It would be enough for us to judge and to test any method in the sound class. Even 3 to 4 seconds is also very long, and you should also know that practically 3 to 4 seconds will contain thousands of samples, because normal CDs or audible file, you can check that, especially for humans, because the maximum frequency is 20,000 hertz that humans can hear, and accordingly the samples will be double the frequency. Double the frequency means 20,000 is the frequency, so we will have at least 40,000. But normally you will see that the sampling rate in these audible files will be like this: 44,100 or so, around this sampling rate. This is for samples per second. And if you have 3 seconds of duration, so you can say multiplied with 3, that will be the total samples in that sound file. So total samples for a sound of length 3 seconds. So, okay, let's come back here. So we have now two sounds together, and we also have a target sound object. And in the first loop, you see we start from index I is equal to 0 and continues until I remains less than get length for S1. Here we have increment I plus plus and target index plus plus, where target is also starting from 0. In between we have reading from S1, S1 dot get sample value, and then target dot set sample value. It requires a target index and the value. That's it. Next is second loop here, just to write zeros, and you see that in this case I is starting from 0 but I remains less than, so this is the terminating criteria here. This is the formula. Formula is simple, that it is taking sampling rate. So sampling rate is like, as I said in the last slide, it can be around 44,100 samples per second. So it is just taking only 10% of this, 0.1. So 10% of 44,000 is like 4,000 samples, almost, approximately. Yeah? Maybe 4,000 plus. So that will be 4,000 plus some samples, in which we will only be writing zeros. So this is the second loop, and in the third loop we are again starting from 0, and this time we have S2 and only reading and then writing. So this is the splice method here, and it is only used for uh, for two sounds. And by the way, we can have here more than one sounds. User can choose more than two sounds. Let's say user keep on choosing more sounds. So in that case, if we have multiple sounds more than two, you can have S1 here, and then you can have S2, and then you may have a target sound that will contain S1 and will contain S2 and some silent here. Now once the target is ready, and let's say there is a third sound S3, so in that case you will reconsider once the S1 and S2 are spliced. Now this whole sound will be considered as S1, and the next sound you can think of that this is your S2. So you will again call the same method in a recursive manner. So you keep on calling the method in a recursive manner, and that method will be receiving two inputs all the times. That means two sounds, together. So you will then create another target that would have this S1, which is the already spliced, and then here you will have this S2, and there will be some silent. So in case if there is a fourth sound, so you again consider this sound as S1, and also add the fourth sound, supplies the fourth sound at the end. So that's how we can actually generalize. hmm, We can generalize the splicing method so that any number of sounds can be spliced, and this uh, can be given to the user. User will select how many supplies, how many sounds. And by the way, you can keep this generalization like uh, as an optional part for your project. If you implement this, you will get some uh, extra point. And in case if you don't go for generalization and you work with only two sounds, so the normal splicing method will remain as it is, and you will get your normal grades for that. So in case if you generalize it, you will get something extra additional, maybe 3-4 points, absolute point you can get for that. Is that clear? Any questions until here? Okay. Now after this splicing, you will see that we have very simple methods here. This is some exercise. You can do that by yourself even. These are two different sounds, S1 and S2. You can copy not the whole sound, only 60% to the target. And then you can have 60% from S2. I says by ignoring first 20% and last 20% from S2. That means if you have a target, so from S1 you can have 60%, like this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 10 samples. You can assume that this is 1 second long duration and this is also 1 second long duration. So the sampling rate of the both sounds is also 10 samples per second. So S1, not the whole sound will be written into the target, but only 60% of S1. So 60% of S1 means until here, from this sample until this sample, and the remaining will be discarded. And from S2, the first two will be discarded here, and starting from this sample until 3, 4, 5, and then also ignore the last 20%. So this part will be written into the target. And but in between this part of S1 and this part of S2, here you have to keep a silent zone. So this will be S1, there will be S2, this is silent zone, and it is S1. So S1 here, S2 here. This silent zone, it says that this, how long this is going to be. It says silent zone of length 40%. Of length 40%. 40% of what? Of the sum of the lengths of S1 and S2. So S1, sum of lengths S1. S1 is actually 10 samples. S2 is also 10 samples. So this is 20%, 20 samples. So sir, 40% of 20, that is 0.4 of 20. So that equals to 8. That means 6 samples are here, 8 samples here, and 6 samples for S2. So in total, the length of the target sound here will be 12, not 12, sorry, 20. 20 samples, and duration is different thing. Length is means number of samples, and duration means time, that how long the time will be considered. We said that this is 1 second of interval, the long duration, and this is also 1 second. So in 1 second there are only 10 samples. So accordingly we can also calculate 6 sample means 600 millisecond here. So this is like, as this part of the target is actually 600 millisecond long. Similarly, S2 is also 600 millisecond long, and this will be 800 millisecond. So total, this is going to be the duration of this target will be 600 milliseconds, 600 milli, 1200 plus 800. So this is going to be 2000 millisecond in total. That means 2 seconds long duration. So this is the answer for this. So you can do this by yourself now. I hope that I have made these points clear. Now, after that, there are few more methods, and they are very simple, like reversing the sound. This is your source, and here, and this is your target. You are reading from the end of S1 of the source and write into the first index of the target. So this will be, source will be decremented and target will be incremented, and that's all. You can see, you can reverse the sound here, nothing complicated, you can do it. Similarly, you can also reverse the 1/2 part of the sound. Like if you have this sound and you can make its first half, and this is the second half. So either you reverse only the second half or you reverse the first half. This is up to you. I mean, it's in the target. Let's say you say that reverse the second half here, this one. So we will write first half as it is into the target, but when the second half comes, when the target goes here, what we will do, we will start reading from the last point and start writing into the target at the next index here. So then this will be read and written into this part, and then and so on. So this is how reversing. You can also reverse first or second half, anything can be done. Then there is a mirroring. For mirroring is also very simple. You have a mirror point in the middle, divide the total length by 2 here, get length, and then divide it by 2. You have a mirror point. This is your point P, say. And what are you going to do is either mirror this one or mirror this one into this. This is the same as mirroring an image. Suppose you have this image and this is the y-axis. You can mirror or reflect this part of the image to the other side. So this sample goes here. This sample goes to the next, and the last sample goes to the first sample. So this is the formula that's the same as this will determine the index, target index, and the value, reading and writing, and you are only executing the loop from 0 to the mirror point. So you start reading from this, stop at this point, and the remaining part will be the same. Yeah, you read from this point, from this index, and write into this index. So this index will be determined by this formula, length minus I minus 1. Then you read the next index and write into this index. Okay. So mirroring is also same. Then there is a blending part. I will take 5 minutes more, but I will finish it today. I hope you guys don't mind. The blending part is the same as the splicing method. That means you have it's like you have two sounds together, S1 and S2. In the target sound, what are we going to do? We will copy S1 as it is, some part of S1, maybe until here, and some part of S2, maybe starting from this point into S2. So this point, this part of the S2 goes into target here, and this part of S1 goes into the target here. But the target have some middle point where the two sounds will be blended. Blended means you can mix two sounds together, and when you play them, you will hear not one sound. It's like two persons are talking to each other at the same time. So you hear two different sounds. And for that, this part of the S1 will be blended with this part of S2. So only for this much duration you will hear two sounds together. And normally this is done how? You will take 50% sample of S1 excuse me, and then take 50% sample from S2, and then you add them together. When you get the total value, sum this value written into the target here. You go to the next index of both sounds, and then can continue this way. So blending is even very similar to, you can see here there are two sounds, and you start from 0 until there is a very long file here. 20,000 is like half a second sound. You read, and then you're reading and then writing. This is first, and in this part it is not blended. You will only hear S1, and in the next part here loop, uh, what are we doing? If you see, from 0 to less than 2000, here we are calculating value first by blending. So you see sound S1, you this is the index plus 2000, because we said that you will write some part of S1 into the target as it is. This is S1. Only this part will be used for blending. That means where S1 will stop here, the next index will be used. So right into the target, here you have some S1, but this part will be blended part. This is S2. So you can say, in other words, you can say that the second half of S1 is blended with second half of S1 is blended with first half of S2. So this is your S2. So then there is S2 dot get sample value at index and then 0.5. Here we do not have 2000 because S2 will start from index 0, and S1 will not start from index 0 because of S1 start at index here, and this is the 2000 index. That's why we say it is index plus 2000, because you have already copied S1 into the target, some part of the S1. This is S1. Here this is S2. So this will be here. So this is your blended part, and lastly the 50% is taken from S1, 50% is taken from S2, and the total value is written into the target here, that is set sample value at. And this is also index plus 2000 because you have already written some values into the target. Now the target index will start from here, 2000. Okay, and the last part is also this one. So this part represent, this is here, and now index will start from 20,000 here, because S2 is also read already from 0 index until this part just before that, and this remains less than 40,000. It is assuming that the total index for S2 is 40,000 here, and set sample value index plus 2000, and S2 is reading the value at the index. So this is the blended part of the, very similar to uh, splicing sounds together. So this will conclude our chapter of sounds. There are two more methods. You can see them here. Changing the frequency, you can do this by yourself. How we can do this is doubling the frequency, and how we can make this, sorry, two more methods are there. This method is very simple, that it will make the frequency of the sound doubles. You can go through this by yourself, and then by halving the frequency is also very simple method, just few lines of code. You can go through this by yourself, and we will now stop here. I will send you the details on the blackboard today about the research paper, and there you will find what are you going to do, and I will also send some list of topics. Okay, so meanwhile, if you have any questions, you can ask by email, or whatever you like. So Thank you very much for your patience, for being here. I appreciate that you spare more time today. All the best. See you, inshallah. Thank you very much for you too. Assalamu alaikum warahmatullahi wabarakatuh.